Hi, thanks for joining me as we do practice 3-2, which is a homework assignment on page 295 of your workbook. So for number 1, I've got a lot of blanks that I have to fill in. I'm going to leave some space over here for the answers, D, E, F, G, and draw all my diagrams around the area for these answers. So we're doing a paragraph proof and filling in some blanks. The other two kinds of proofs were 2-column, my favorite, and flow proof. Good job. So we're given some information about this three-dimensional diagram, and we're going to go from this top side of the stick of butter to proving some angles or some lines that are parallel to the front side of this stick of butter. So first, we're talking about let's see what I can choose for a highlighter here. So first we're talking about this angle here, RQT. Then we're talking about angle QTS. Then we've got TSV, so that's this guy right here, and SVU right here. All right, so those are the ones that I'm going to be working with, and we have to get from this top surface to the front surface with our proof. So first, here we go. Angle, because angle RQT and QTS are supplementary, that was given to us. RQT and QTS are what kind of angles? Well, wait a minute. I'm just going to reproduce the top part of this diagram. I've got Q, R, T, and S. So now I'm looking down on the top of this stick of butter. And I'm talking about this angle here and this angle here. QT, the angle at vertex Q, and the top side angle at vertex T. So these two angles were on the same side of a transversal, and they were in between the two lines that I'm hoping to find out something about being parallel. So that makes them same side interior angles. So there we go. These two were same side interior. And now, by the same side interior angles theorem, we have two lines that must be parallel. Which two lines? Well, here was our transversal, so it was these two guys that were parallel. So that means line QR and line TS that are now parallel. So the first blank is for QR, and the second blank is for TS. Let's keep going, because TSV and SVU are supplementary. Oh, where are we? TSV and SVU. So now I'm looking at this front side of the stick of butter. I've got a transversal here, and I've got two angles that happen to be on the same side of that transversal, and they're on the interior of what I'm hoping will be some parallel lines. We have, again, we can call these same side interior angles. And I'm okay with it if you start abbreviating these SSINT, same side interior. So now we're up to letter D. By the theorem, guess what? It's the exact same thing that they just did up here. By the same side interior angles theorem, same side interior angles theorem, THM is a traditional way to abbreviate theorem. Line TS is parallel to line UV. TS parallel to UV. Okay, got it. Now, because line QR and line UV, so now we're talking about this line in the back, QR, and UV, QR and UV, are both parallel to something else. Guess what the something is? It's this front top line right here, line TS. QR is therefore parallel to UV because of what? Theorem 3-5, which happens to be converse of the corresponding angles theorem. Okay, let's move on. Which lines or segments are parallel? Well, let's see here. I know that 65 and 110 are corresponding angles if the corresponding, I'm sorry, I said that wrong. 65 and 110 are same side interior angles with this as the transversal and these as the things that could be the parallel lines. As long as these same side interior angles add up to 180 equals 180, then my lines are parallel. Is that true? Well, 110 plus 65 does not equal 180, so the lines are not parallel. Okay, but let's look at a different set of lines. Watch this. If I circle 115 and 65, you already know that that equals 180. So as long as they're same side interior angles, then I do have parallel lines. Well, here are the lines that form these two angles. I got that one, I got this one, so now I've got this corner, and this one gives me this angle right here. So this must be the transversal, and these must be the candidates for parallelness. Is that a word? So 115 plus 65 does equal 180, so my lines are parallel. So now the question is, which lines are parallel? So here's what you really need for the answer to this question. We've got this and this adding up to 180, so you would say that line L is parallel to line M. L parallel to M because of same side interior. Actually, I should say this, the converse of same side interior angles theorem. Over here, number 3. These arcs show me that I have congruent angles. So now if I have this angle and this angle are congruent, and this one too, they're all congruent to each other, which ones could be parallel? Well, let's consider 2 at a time here. This angle is made up of this line and this line. This angle is made up of the same one and this one over here. So my candidates for parallel would be line L and line O. Now, these are going to be same side interior angles. Same side interior. Okay, I know the same side interior angles theorem needs the angles to add up to 180. Is that what they're telling me here? No, it's not. They're telling me that same side interior are congruent. When has that ever helped us? It doesn't help us at all. So knowing same side interior angles are congruent doesn't tell us anything. We can't make a conclusion about any of these lines being parallel. And so simply because this argument didn't work, if we look around the corner here and talk about the angle at O and the angle down here, again, congruent, but same side interior being congruent is not helpful. We always need same side interior to add up to 180. Number 4, we have 2 lines that could possibly be parallel, and let's look at this transversal. same side, interior angles. Do they add up to 180? Yes, they do. So that means that the top line and the bottom line are the parallel ones, and this was the transversal. So for number 4, you would say BC is parallel to AD. And by the way, number 3, the answer is none. Here's your answer for number 2, number 3, number 4. Okay, keep going. Number 5, we have, oh, and the reason here is converse of same side interior angles theorem. All right, great. Number 5. This is a little tricky because the lines that we see that could possibly be parallel are here and here, or maybe they're here and here. So I'm going to pick up some of this and redraw it so that I can see what could possibly be congruent. Now, I'm going to choose the 2 blue lines. And now, where is the transversal that's going to help me? It's actually going to be this guy right here, because I'm going to care about the 30-degree angle here and the other 30-degree angle here. So that looks like this. And now I've got this angle up here and this angle down here. What do we call those? If these are the 2 lines that could be parallel, and this is the transversal, that would make this one and this one corresponding angles. Great. Now, do corresponding angles have to be congruent, or do they have to add up to 180? That's right. They have to be congruent. So, are my corresponding angles congruent? Yep. Their measures are equal, so they must be congruent. That means that this line here with this line here, those are my parallel lines. So you would write for number 5, line RT, which is right here, is parallel to line HU because of the converse of corresponding angles theorem. Now, do you remember why we're talking about converses? The original statements say, if the lines are parallel, then the angles are congruent. Converse switches it around. If the angles are congruent, then the lines are parallel. And sure enough, we have information about the angles. We're trying to find information, trying to draw a conclusion about the parallel. Okay, number 6. There are a lot of candidates here. Let me start with, let's try this. If I use AC and GI with this as a transversal, do you see any pairs of angles that are actually in a relationship? If this AC, these 2 horizontal ones, are the candidates for parallel, they're showing me something about angle A. Oh no, there's no angle down here that has that same arc to show that they're congruent or that they can be matched up. So anytime you're drawing these diagrams, you can only start with conclusions, start making conclusions about things that are joined by the intersection of 3 lines. 2 are parallel, 1's a transversal. Again, if I think about those as possible candidates for parallel, here's a transversal, but I don't have any angles up here at this intersection to match up with the information, this little given of a congruent symbol down here. So that can't be a possibility for who's congruent to whom. Let's try one more. If I'm trying to prove AC parallel to GI, what if I use this as a transversal? No, I know nothing about this intersection. I know only one thing about the lower intersection. So let's think about this how can I pick lines to be parallel and a transversal so that I end up with a relationship here. Okay, where were we? I was looking for a set of lines to be candidates for parallel with a transversal, and I'm trying to get them all to happen by just drawing 3 lines. Well, this set of angles can be drawn using only 3 lines. Here's 1 line, 2 lines, 3 lines. Yay! So these would be my candidates for parallel. Here's my transversal, which makes this angle and this angle have what relationship? Corresponding. So B, uh-oh, I can't see what that is. There we go, now I can see it. BH parallel to CI. Because of the converse of corresponding angles theorem. Number 7. Looks like we've got a bunch of interior angles here, and I see angle measurements, so I'm either looking for the same number or I'm looking for 2 numbers to add up to 180. So how about this? By the way, the 79 goes to this angle here, and look, 101 goes to this angle here, so 101 plus 79, that equals 180. That's very interesting, because if this line and this line and this line, which make up those 2 angles, then I can call this one my transversal, and these 2 have to be parallel because I've got same side interior angles that are adding up to 180, or that are supplementary. So I've got line A parallel to line B, and I don't actually have to put the arrow above these because that's how they've named them. When I'm using actual points that lie on these lines, then I have to use that line symbol above it. So A is actually the name of the line. So I've got A parallel to B because of the converse of same side interior angles theorem, THM. All right, so now we have to do some algebra with this. Find a value for x, which makes the lines parallel. All right, well, let's see. Here, I've got my A, I got my T, so this is my transversal, which makes this angle here with this angle here have what relationship? Well, they're on the same side of the transversal, and they're on the outside of the parallel, so same side exterior angles. Anytime I'm doing same side, I know I've got to add up to 180. So now I'm going to say this angle plus this angle must equal 180. Let me do that math over here. 93 plus x plus 44 is 180. I can simplify these 2. Equals 137. So now I've got x plus 137 equals 180. And so I've got x, subtract 137 from both sides. And I'm left with x equals 43. Number 9. Here's the transversal. Here are my 2 candidates for parallel lines. The angles that they're indicating are in here for the x plus 20 and over here for the x minus 20. Well, what relationship would that be? They're on the same side of the transversal on the interior of the possibly parallel lines, so I can set this up to be what? Congruent or supplementary? Well, they're same side interior angles, so same side are going to do the 180 thing. So I've got the x plus 20 plus the x minus 20 equals 180. I can simplify the 20 and the negative 20. Cancels out to be 0. The x with the x, that's 2x. Divide both sides by 2. X equals 90. Number 10. Gonna see if I can squeeze all these in here. Number 10, transversal, possibly parallel. The angles that I'm talking about are up here and down here. What relationship would these have? Maybe you're saying, I don't have a name for these because they're on alternate sides of the transversal, but one of them is on the outside, one of them is on the inside. Well, guess what? We actually get to use some logic here. And if I know that this is 3x, what could you tell me about this angle down here? Well, that would be corresponding to the 3x, and corresponding angles are congruent, so this must also be 3x. Aha! Now we've got it. We have this angle in here, we have this angle over here, and look, they make a straight line. So the setup for number 10 will actually be a lot like the previous one, where we add these two angles and get 180 because it's a straight line. So I got the 3x plus the 2x minus 10 equals 180. Simplify these, 5x, add 10 to both sides, 5x equals 190. X must be 38. Okay, number 11. We've got x minus 30 over here, and we've got a 70-degree angle here. Do you know why they put this angle in here? That's right, to confuse you. Okay, so we can ignore that one. So now, here's my transversal. Here are the two lines that I need to make parallel. If I'm talking about the angle in here and the angle over here, what's the name for that relationship? They're on alternate sides of the transversal and on the interior of the two possibly parallel lines. So they are alternate interior angles, which means that they will be congruent. So 70 equals x minus 30. Add 30 to both sides, and x is 100. Number 12. A and T are the things that I care about. Those are what I'm trying to prove parallel. Now, they're telling me something about this angle in here. All right, well, if that's the angle that they're talking about, if I knew anything about this angle, then they would be supplementary. If I knew something about this angle, the blue with the yellow, those would be congruent. If I knew something about the yellow with the angle in here, those would be alternate interior. Those would be congruent. So far I haven't highlighted the angle that really would help me here, and it would be this one. But just like we did in number 10, we can draw some other conclusions. So if this is a line and this angle right here is 130, what does this angle have to be? Yeah, 50. How come? Well, these are straight lines, so that's 180 degrees, and that means it's 130 plus something. Well, the something has to be 50. So now, I gotta clean this up. We just figured out that this angle in here is 50 degrees, and this angle right here is x minus 20. So if this is my transversal, and these are the lines I'm trying to prove are parallel, then the 50 with the x minus 20 would be what? Corresponding angles. So now I can say 50 equals x minus 20, add 20 to both sides, and x equals 70. Great. Last one, 13. The angles that we care, the lines that we're trying to prove parallel are A with T. Now, let's highlight this very carefully here. There's one of the angles that I know something about. So let me just highlight, or rather trace over, the line that would make that transversal be something helpful with these two lines that I'm trying to prove parallel. Well, if I knew something about, say, this one right here, then again I would have some corresponding angles. But I don't know anything about that. Can I figure something out? Absolutely. So here's how I would do it. I would say that the angle in here, the 2x minus 20, and this angle right here, x plus 35, those two would add up with my yellow one to make 180, right? Yeah, because it makes a straight line. So this will be a two-step problem. I've got 2x minus 20 plus x plus 35 plus one more thing that I don't actually know. But wait, I do know something. This yellow angle right here, which is what I need to fill in right here, along with this angle right here, those would be corresponding angles. Corresponding angles are congruent. So I could actually substitute the value right here for this angle, this yellow angle that I need. So 2x minus 20 plus x plus 35 plus 2x minus 75 has to add up to 180. I've got a 2x, an x, and another 2x, so that's 5 x's. And I've got negative 20, positive 35, and negative 75, which adds up to negative 60, and that equals 180. So add 60 to both sides. 5x equals 240, x equals 48. Nice. All done.